This program is brought to you by the University of Michigan. For more information, visit umich.edu.
So, without further ado, we have Jim Cogswell to introduce Chris Impey.
Good evening. When I walk out at night, I glimpse a point of light between the clouds. Maybe about the size you would be if I could see you, say, sitting at the counter at Blimpie's. From here, for a moment, incandescent. What can I know about that point of light that is untethered to what I might know about you? My memory and my imagination feed on you, depend on you. I pull you into myself because I am at the center of everything I know. But what can I do to understand that star? To paraphrase the social theorist Roberto Unger, one day you and I walk out into a world that is not ours to understand more than a little, or to control hardly at all. A world that is real and dense and dark. Each one of us will be asked to understand that we are not the center. And in the midst of what lies out there, we are very close to nothing. This possibility lies gaping before us, a deep tear in our world. We will wear this knowledge, each one of us, in our own way, if we can bear to wear it at all. How many days in a row could you eat such knowledge for breakfast? Walk with it to the bus. See it in the eyes of your lovers and friends. Unimaginable. Put it away. I wonder especially how an astronomer manages with daily things like breakfast. Chris Impey appears to manage quite well. He's an observational cosmologist. He studies gravitational lensing, whatever that is. The evolution and structure of galaxies, ultra-faint galaxies, active galaxies, and quasars. Cool. He has had 14 projects approved for observation with the Hubble Space Telescope. He also manages to do this with passion. How did that happen? This man has somehow won every teaching award devised by humankind. Certainly at the University of Arizona, where he's a university distinguished professor, where he runs the nation's largest undergraduate majors program in astronomy. He was recognized as Arizona Professor of the Year in 2002 and was named Distinguished Teaching Scholar by the National Science Foundation, the highest recognition that the NSF gives for excellence in both teaching and research. As a professor, he has pioneered curriculum development in astrobiology and is primary investigator on a major grant to explore issues at the interface of science and religion. He is currently vice president of the American Astronomical Society and serves on its executive council and its astronomy education board. Now, Dr. Impey is a native of Scotland, as if that explained everything. He received the Bachelor of Science degree in physics from the University of London and the doctorate in astronomy from the University of Edinburgh. Several years ago, I attended an art science conference at the Adler Planetarium in Chicago, where he was a presenter. Before he was finished, I wanted already to have him here with us at the Michigan Theater. And I don't want to wait any longer. Please join me in welcoming Dr. Chris Impey.
Thanks very much. Great introduction. I'm really pleased to be here, and it's a little unusual for me to be welcomed somewhere under the auspices of a School of Art and Design because, you know, I am basically a nerd and am maybe on my better days even a geek. Although I have heard that artists can be nerds and geeks too. And I wear that proudly now because I've realized that being a nerd mostly means that you get your head and your heart so deeply into something that you forget about personal hygiene and who your friends are and where you live and where you parked your car and all those things. So I hope you can join me in that type of world just for a little while. But what I'm really going to talk about is something a little more somber, or the setup for my talk, if you like, the art of science. Because these are two words that we don't see together very often. All of you have grown up in a world with an almost perfect disconnect between art and science. In this talk and in general, I use the word art broadly to mean all the visual arts, the performing arts, creative arts in general, and science generally too, although my examples will be astronomy. It's very unfortunate because, as I hope to convince you, my only hidden agenda is to convince you that the acts of creation of the artist and the scientist, the nature of the inspiration, the mystical and even magical way we learn about ourselves through the universe, those are modes that are shared by scientists and artists alike, who have a lot to teach each other. So we start our exploration with some quotes that are designed to provoke. We have a physicist saying, when I have to choose between the true and the beautiful, I choose the beautiful. That's striking. That's a scientist elevating aesthetics above everything, even veracity. We have the poet telling us that metaphors are imperfect, and that's the beauty of them. That's fine for a poet, but what has that got to do with science? Well, no scientist has ever seen an electron, has ever touched a magnetic field. Scientists use models, metaphors, and analogies all the time in their work. They rely on them. And they're not just crutches, the inadequacy of language. They're vital ways we convey things that are sometimes ineffable, that can otherwise only be described in mathematics. And then we have a Nobel Prize-winning physicist saying, research is what I do when I don't know what I'm doing. Well, maybe you can get away with saying things like that when you've won a Nobel Prize. But what Murray Gell-Mann was saying is that at the edge of knowledge is where it gets interesting. You all, I'm sure, have had times in your schooling, in maybe your university career, but I hope not, where you felt like you were having facts pounded into you, or poured over you, or flung at you, and that's what it all seemed to be about. And for many, that is the experience of science at school or in college. But it's much more interesting when we get to how we know what we know and how science actually works. And that's where I'm going to take you tonight, to the place where you don't know what you're doing. The first is the art of exploration. Science is about seeing. It's about seeing the world. It's not just painters that see. It's not just writers and poets that see. Science is based on seeing. But it's seeing writ large, not just seeing with the eyes. Sometimes it takes an artist to tell us how we should see. At the top you see a medieval woodcut showing, obviously erroneously, the trajectory of a cannonball. But it took the artist, hundreds of years later, to show the beautiful parabolic trajectory of any object moving in the Earth's gravity. What about the telescope? Or what about how we see in space? What is real? What is out there? The pictures, the drawings on the left, were all made by different people, each one, within the first 40 years after the invention of the telescope. And if I asked you which one was Saturn, how would you know? Well, now, of course, you would know. We've sent a spacecraft there, and we've seen its beautiful gossamer thin rings. But the telescope, soon after its invention, was a flawed device, the frontier of technology in 1600. And nobody knew what Saturn really looked like. When you push the envelope of technology, your information is flawed. Your tools are imperfect, and that's where you have to work when you're deriving new knowledge. And on the right, we're reminded that the scientist and the artist are one. Before the invention of photography, we see Galileo's beautiful watercolor sketches, not just with artistic merit in their own right, but conveying a pivotal moment in human history when we realized that the moon was not some ethereal object or mystical. It was a world with valleys and mountains like the Earth. Sometimes we don't have to use sound. We use other modes of understanding nature. These are the orbits of the solar system turned into sounds, as heard from the Earth. Each new tone, an outer planet, starting with Mercury. This is Kepler's harmony of the spheres. At the time of Pythagoras, the harmony of the spheres was meant literally, that someone suitably intelligent or enlightened could actually hear, could audibly hear the harmony of the spheres, the celestial bodies in motion. Now, to give you a more modern example, you will hear, compressed into a few short seconds, the first 300,000 years after the Big Bang, an event that took place 13.7 billion years ago. So this is the sonification, if you like, of the ripples and motions of gravity in the infant universe. We've learned how to see the universe in different ways. There have really only been several revolutions in astronomy. For most of history, astronomy was naked eye. The invention of the telescope was the first assist to human senses. And Galileo, although he didn't invent the telescope, was the first to point it at the heavens and learn about space. We should recall that Galileo's first telescope was amazingly primitive. Its lenses 1/4 inch across. You could reproduce it with a few dollars worth of components that you buy at a hardware store. But it opened up our eyes to the universe and to the fact that we might not be the center of this vast creation. In the intervening time, we've improved the light-gathering power of telescopes by factors of millions over Galileo's humble eyepiece. Then, 60 or 70 years ago, electronic technology opened up the electromagnetic spectrum. Less familiar to most people, this is a revolution just as major as the invention of the telescope. Because for the history of astronomy over all time, we'd seen the universe as if with blinkers, through a narrow band of light from the bluest blue to the reddest red, a factor of 2 in wavelength. Now we can observe the universe, even single astronomical objects, over factors of trillions in wavelength, from high-energy gamma rays to radio waves meters long. A final revolution is occurring right now. We're building the first detectors to see the universe in gravity. Again, to this point, everything we've learned about the universe has been done in terms of light or radiation. When we first put on our gravity goggles, our gravity eyepieces, and see the world and the universe as gravity has sculpted it, we will learn amazing things. So we extend our vision, and the extension of vision is an important part of how we learn about the universe. But sometimes we use sense extenders in different ways. We use the ideas of physics and astronomy to take us to places where we haven't been, but we might one day go. And eventually, we will use technology as projections of ourselves in space.